Good afternoon, this is Lee McWhorter. Welcome back to System Administration Part 2. This is the second part of our lecture workshop for the class that began 514. Last week we covered through the first 5 lessons. Primarily, we had ended up, sorry, my chair back is acting up. We had ended up not quite getting all the way through with scripting last week. We got through talking about it being beginning programming, things like variables and stuff like that, I believe, but didn't actually get into any examples. So I'm going to show a couple quick examples and then we'll blow through the material for today. Today we have the remaining lessons to cover, and this is a little overview on vulnerability and pen testing, some discussion about secure protocols, secure networks and systems, and secure deployment, and then we just touched briefly on our last lesson on implications of what we call embedded systems or the Internet of Things, IoT. So give me just 1 second here. Move some stuff off of my keyboard so I can get access to it. And let me set up, minimize some junk out of the way here. What I want to do is I'm going to clearing up from our previous run of this. Okie dokie. So what I'm going to do is I'm going to come in here, my controls back. There we go. I'm going to share my screen. I'm just going to share my whole desktop actually. And you can see that I've made a folder here on my desktop called test scripts. And what I'm going to do is give you a little rundown. Now, there's a couple different things you need to be aware of. I think we may have covered this last week because I remember moving this icon. I had to move it back. But one of the things about PowerShell scripting, remember, is that you have to make a custom version of the shortcut that you add on this space hyphen execution policy unrestricted to the end, so that when you run PowerShell via this custom shortcut, it'll actually enable the ability to run scripts. That's the sort of one trick about PowerShell scripts. And then, of course, there is a couple other things just so you kind of walk you through it. In this folder, I already have one. Let me put my PowerShell icon back. I already have one script, which I'll show you later. Just as it's not one I wrote, but it's one that's a sample we can take a look at. But I'm gonna pretend I want to write some scripts, right? So I want to write some scripts in here. So you can put scripts anywhere, of course. It doesn't have to be the desktop, but you just have to make sure you keep track of where you are and thus also where your PowerShell prompt is on the path, so that you make sure you call things correctly. And the other thing is PowerShell scripts have a PS1 extension, and of course, in Windows, when something like this says Windows PowerShell. So if I double click that, it would actually try to run it launch in PowerShell, which I don't want to do. And so if I come in here and say I want to create a new script, it's really going to be a text file. Remember we talked about that last week. All scripts are just text files. So if I say I want to have, say, a test script, I've got to change the extension to PS1. And of course, it's going to ask me about that. And I say, yeah. And now, of course, if I double click on it, once again, it thinks it's a PowerShell. It's going to try to run in PowerShell, but we know it's 0 bytes. It's a brand new empty file. So how do I edit it? Well, the best thing that I tell people to do is just, you can use any editor, VS Code, other things if you're, if you got that already set up for other coding. When you get later in the program to the Python, you will, at least the Python programming class, you'll get exposed to that. But this can all be done in Notepad, or say VI or VM or Nano on Linux when we do bash scripting. But what I just do is I just launch a copy of Notepad, and then I drag that file into there. You'll see my title up here, test PS1. So now when I come in here, I can start to write code. Now, remember what I talked about. At its most simple, shell scripting is really just a collection of commands, that you could have typed at the prompt. So, I mean, to make the simplest script kind of imaginable, we can do something like this. You can see it says take a directory of the C:\/ or the root of the drive. So I save that script, and then if I double click it, the problem with that is that it's going to run the default PowerShell, which doesn't have the permissions to run scripts. So I'm going to launch my PowerShell that I know I've added that execution policy and restriction on at the end, so that when it finally launches here, I'll have a PowerShell prompt and I'll be able to work with it. Now, when you launch PowerShell, usually by default, this is pretty common. You'll see that it tells me, it always tells you where you are, but it's common that it drops you in your own sort of home folder, sort of like when you log into a Linux machine. You get logged into your own home folder. And so one of the things about that is that I can't run test.ps1 from here because it doesn't exist here. I'm going to get an error that it's not there, right? So what I have to do is I either have to provide the full path, which I can do, or what I tell you people, that the reason I created that test scripts on the desktop is, of course, in my home directory, if you look, this is where all your stuff is. Matter of fact, there's your desktop. It's actually kind of funny. Windows has for years kind of implied that the desktop, or maybe this PC or whatever, is at the very top of the whole tree. But because every individual user can have their own desktop, really desktops are underneath C user's username desktop. And if there's more than one computer, then more than one user, there'll be more than one desktop. But so I want to so I'm going to use the CD command. And once again, I'm using the tab key to let that autocomplete for me once I got DE in, because there's documents and downloads, so D wasn't enough. But DE tab finishes out the desktop. And then when I change there, of course, I can see the stuff on my desktop, including my test scripts. Oops. Oh, I see what's going on. It's off the screen. So I want to change into test scripts. Now you'll notice it's kind of hard to read. I know color out, but what it had to do was it had to put it in single quotes because there's a space in there. But now you'll see I'm in that folder. I'm actually, and this is sort of the other trick. Beyond setting up your PowerShell so it can actually run scripts, you then have to make sure that you change, you can use the cd ... like we learned in Linux to go back a folder. And you only have to do partial hit tab. So, but you want to navigate to where your PowerShell, where your scripts are. There is a way, of course, to just get a PowerShell prompt, but that once again would be a default prompt, and we want our PowerShell that we know can run scripts. So I've run that one, and I've switched into the directory. And of course, if I take a dir, which is equivalent to the ls on Linux, you'll see that that's what I have. I have my scripts here. So now if I run test, you'll see that it did exactly what I told it to do. That at its simplest is scripting. They're just series of commands. So if you find that you have to every month sit down and do these 10 commands on your server to back up these files and delete these files and do X, Y, and Z, then instead of sit there and type those same 10 commands every month and possibly get one of them wrong every other month, sit down, write the script, write the lines out, and then save that script. And then when it's time to do your work every month, you can run that script just like that. Now, of course, as we talked about, and in this one lesson, I'm not expecting to turn you into a full programmer, just get you the basics. But you can do things like take input from users, and you can have more complex variables, and of course, then make these scripts more useful potentially. You could have the script ask you what folder do you want it to work on, like the one in the lesson, or you could ask other types of questions. And of course, you can have all kinds of much more complex scripts. And in the short time I have, and the level that we're only trying to get to, I don't want to get too deep there and definitely not scare you off. But let's take a look at this other script. So I'm going to bring back up, apparently I killed it. So I'm going to start another notepad. And I'm going to drag this memory script in. I want you to take a look at this. Now, this is a much more complex script, obviously. It was written by Rob here. And so I'm not giving credit where credit's due. You'll notice that we're using the hashtags or pound signs as the comments. So memory script version, whatever, some information about how it works, who wrote it, blah, blah, blah. And then it begins to set up some parameter variables. One of the things that it gets is the actual computer's information. Then we start setting up, and of course this script, one of the things that is interesting is that PowerShell actually can be added to Linux. The PowerShell core can be put on a Linux machine. Just like nowadays, you can actually run basically a bash prompt on Windows. So it's funny how these languages are crossing to support each other. But you'll see because of that, this programmer's done some if logic to see, is it a Linux machine, then I'm going to go about it this way. If it's a Windows machine, I'm going to go about it this way. And then you'll see using these write lines, write host, write to the screen lines, after it's done its calculations of figuring out how much memory is available, it's going to then output this information in certain formats. And these are a little more complex than just, writing back hello world, but the principle's the same. We're going to, some of it, like the physical memory, that's a string, that's put in quotes, right? So it's just going to print that. But then pad write 16, whatever, that's going to be a value that it's going to pull. So anyway, let's run this script and see what it looks like. And so if we come back over here to our PowerShell, and this time we run the memory, it says running scripts, only ones you trust. Now this is a warning about this one because it is a more complex script than just doing a directory. It sees some functionality, and so it's giving me a warning. I'm going to say that I want this, I'm going to hit the R for running just once in this case. And you'll see that the script ran off. It obviously did its if-then look and said, okay, this isn't a Linux box, so we're going to go down to that second block of code, and we're going to then calculate the memory. And then you see it comes back, and there's that string, physical memory. And then, it basically draws all this stuff out and makes a nice column. And you can actually see some of this. Did I lose it again? Gosh darn it. Why do I keep closing my notepad today? But you can see this stuff. So this first few lines, you see it says it printed physical memory, and then it padded some spaces, but no new line. It then printed byte and padded some spaces, printed KB, and then drew out 49 times the equal sign. And we can see that right here. This is those first two lines of output. And then the memory, of course, he begins to pull these strings of memory that is, the free is the variable in this case, which we calculated up here by using the get operation here on the computer name and free physical memory, total visible physical memory. So it just ran system commands, but you can see this script can be run on Linux or Windows because it has the functionality of doing the appropriate commands as need be, depending upon which operating system it's on. And then it has some fancy, padding and stuff like that to make a nice little display. And basically all that code basically generates as a memory report. And we get all the data. And of course, if you ran it on your system, you have a different set of results than when I run it on mine. And so you can see that, this is a script this person wrote, obviously, to be able to just copy into whichever system, and he can run it on a Linux box and get that information. And of course, you can basically sort of in a early version of sort of module, you'll learn more about it in the programming class later, but we can have multiple scripts. And so like and this I actually know that that's one of the things that is possible with Rob's scripts. I have a number of his scripts that I've looked at and that I even use a couple of them. But because they're standalone, you technically could do something like this. I guess that'll be my last quick example. Let me not close I'm going to switch back to my little test script. And you see what I've done here is I've just, once again, added a line. I want to do something. Right now, everything has to be in the same directory or I have to put full pathing. But now if I come back and I run, why am I lit up here? Interesting. Never mind. Thought maybe I had a chat or some question or something if somebody popped into the room, but I guess not. So if I run test again, you'll see that it actually throws a fit about the way I did that. The term memory is not recognized, so I'm not calling that correctly in this context. I think what I did wrong was, let me see here. I didn't give it the dot to basically say to run the program right here. Let me try that again. Let's see if that works. There we go. You see what happened? Now it ran the first line, did the directory of drive C for me, and now it's asking me, of course, the security about the second script, and I say yes. And thus in one script, and so you could see how you could write a number of little scripts to go do certain tasks and then string them together by one sort of master control script. And that's sort of what Rob's script is about, is that you can run a number of his scripts together to get whatever kind of custom reports you want on the system in question. So I think that gives you an idea of PowerShell. Now, just to show you a very, very quick, while I'm still sharing all this stuff, I'm going to run over here to one of my little test server. And to try to make this a little easier, change settings, we want to go here. Okay, I'm not sure why my font dialog box is taking so long, but there we go. All right, so I'm going to log in on my server over here. And then I believe, well, I have some of this junk, but yeah, I have a few different scripts here, I believe, already from previous stuff. I may have a folder of them. Oh, I thought I did. Oh, well, there's snow. Okay, let's see if that's what I think it is. I think I know what that is. Snow dot. Okay, so this is a bash script, and I've used the more command just to bring it up. And you can see that it starts off. That's one thing that's unique about bash scripts. They always start off with that bang bash line at the top, as they call it. And it's a comment, but it's a special because it has the exclamation. Basically, it's the path to bash. By default, that's going to be that line almost exclusively on every system. There could be some reason that was not the case, but in most cases, it will be bin bash is where the bash shell is. And so we're going to run this program through the bash interpreter, basically, the bash prompt. And you can see that it sets up some variables for lines and columns, declares snowflake and last flake as some variables, it clears the screen, and then it has this move flake function. And if the flake is this, blah, 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 I'm not trying to get you to understand this full thing, but I'll show you how this works here in a second. And so this little script is just kind of a cute little script, but it does give you an idea of some fors and ifs and some flow control. Now, if we take a look at it, if I try to run snow.sh, I'm going to get a permission denied error. Now, hold it. If we look at that file right here, I own this file. I wrote it. And so what the heck? What's missing? Well, remember permissions. This is the thing that's different, or the one little trick about bash scripting. Over on Windows, to make a script run, we have to change the execution mode, if you will, so that it will allow us to run a script. But here, we have to actually just make the file executable. See, these files are only read, write, read, read. So even I can't execute it. But if I use the chmod command we learned in Network Foundations to change this to, instead of right now it's 644, which is read, write, read, read, I want to change this to 744. Now that will give me all permissions, and we'll take a look. You'll see now it changes it to green. It's got an asterisk because it's executable. I can execute it, but nobody else can. But now, if I use my up arrow to go back and repeat, why is that not working? Now that is hilarious. I don't like it when demos don't work because I've done this program before. Command not found. What are you talking about? Just for giggles, I'm going to try 755. I don't think it's a permission issue, but I've run this before, and bash is obviously in bin bash. So what am I missing today? Sorry. I hate it when a demo doesn't work. That is really interesting. I see no reason why this shouldn't work, and it has worked before. That is most strange. Let's try a full path. Command not found. I'm so sorry for that. Let me try another machine. See if I have it on my personal one. I'm only going to take so much more on this. I'm sorry, folks, but can't remember if I have any scripts for playing with over here or not. Nothing it does. So it wasn't that one. Darn it. Well, darn it. I think I must have done it in a VM or I'm not set up to do so. But the trick that I really wanted to show, especially since you got lessons to run, if you decide to use Bash in a VM from, say, Network Foundations instead of using PowerShell to do the exercises, then the trick is that you do have to change the permission of the file. I guess we could, I could do, let me just see if that'll work real fast, just for purposes of, because I've got to move on, but so if I was to say touch a new file, and then I'm going to use nano. So touch is the way, of course, we use that in Network Foundations to create an empty file, sort of like right-clicking and creating a new text file on Windows. And then I'm going to nano that, and so then we're going to have to put in our, oops, yeah, bin bash. And then I'm going to do something just as simple as that, sort of like the previous one. So now my test script, of course, the same deal. Test script by itself is not auto-completing on tab because it's not an executable file. And even if I type it in, of course, it's going to fail. Permission denied. So 755 test script. Helps if I type correctly. Test script. And there we go. So a script can't run. I'm not exactly sure what is up with that snow one. That's really annoying, actually, that one didn't work because it's kind of cute, but I just don't honestly see what the problem is and what it's throwing a fit about because it doesn't do anything but sort of default stuff. I'm going to resave it and see if maybe that'll help me. Oops. Nope, still not. Something wrong with that. I'll have to see if I can fix that one for a later day. But you can see that my little test script, which was just sort of like the previous one I wrote on PowerShell, all I did was do an ls/ to take a look at the root directory, but that accomplished its thing. And so the trick is, though, you do have to do that chmod 755, or at least 7 something. Give yourself permission to run the file. Because by default, when you create a file, it's usually just a read only to everybody and writable to you. And so that is sort of the trick of bash scripting, is to make sure you set the permissions for execute purposes. And then for PowerShell scripting, the trick is to make sure that you have set up the PowerShell itself so that you can run scripts, and then to make sure you're in the appropriate directory. One thing that's kind of nice about bash scripting is, generally speaking, since you're already at that command prompt and you're doing things with nano, like you saw me just throw it all together, then more times than not you're in the directory where you created the script. But that still applies there too. If you can't just log in and type some script name that's in a different folder. If it's not on the path, then it won't obviously automatically execute. You'll have to put the full path in or change to that directory. So a quick little scripting review. Sorry, that was just a cute little snowflake generating thing, but it was a script that sort of like I intended to run as a little more complex example. As you can see, at the simplest, they are just collections of commands, and then as you start to add some programming into it, you can make them more complex. So let's get on, since that took longer than I thought for shell scripting. But so we're going to go real quickly through the remaining lessons. Particularly the lesson 6 here, which is on vulnerability and pen testing. This is primarily an overview because you're going to spend a lot of time doing both in multiple courses going forward. As a matter of fact, the folks that finish up this week and move into network defense next week will we'll definitely be getting more into vulnerability and penetration testing. So what are they? Well, they are forms of testing and scanning that are helping us, to ensure that our network is secure. But they are different. A lot of times people sometimes think that these are the same, but they're not. They're two sides of, in a way, sometimes of the same coin. But vulnerability testing is about scanning to detect potential vulnerabilities that could be exploited, but doing no exploitation at all. So when we are doing a vulnerability assessment, we are doing port scanning and enumeration across the network. We're looking at what servers are up, what ports are open, what network shares might be available, what hosts are available, what information is being displayed. And of course, if we see a port open that we didn't expect to be open, then that's probably a problem and we might have a vulnerability there. Or even if we expected ports to be open, and because of the fact that there are services back behind there, websites and things, then obviously we have potential vulnerabilities, and we might scan further and scan the web and see if it's vulnerable to command or SQL injection or things like that. But vulnerability stops at that point. And vulnerability assessments are done fairly often, actually. Even bigger companies might do them literally monthly or weekly, depending on the level of security need. And different system administrators, security system administrators, might run small versions just on the systems under their purview every so often. Many times that'll be dictated in policy. Other times it'll be up to sort of what's been the best practice so far, or be left to that engineering question or system administrator question. But the idea is that we're going to be using various tools, some basic tools like Nmap, Network Mapper. You'll learn a lot about that in the next class, and a number you'll see it again and again, actually, throughout the rest of your career. It's one of the most common and useful tools, but we'll be looking at other types of scanners. And so we have vulnerability assessment systems that can scan a website, that can scan a local host, they can scan a network. And then there are some integrated, like we're going to look at something called the Open Vulnerability Assessment System that is one of the more intensive exercises we'll do in network defense that shows you that you can scan a system for a wide range of vulnerabilities. And there's all different kinds of software. We'll talk about it in later lessons. But that's vulnerability testing, is the idea that we are going to take a look at it and then be able to to come back with a report. These are the systems that are open. These are the servers that are up, the ports that are open. And of course, if we've conducted a baseline earlier, we can compare and just make sure nothing's changed that we're not expecting to change. Now, pen testing is going beyond vulnerability testing. Now, in many cases, a pen tester will do vulnerability assessment. That makes sense, especially if they're a third party, like if they've been brought in externally, because a pen tester's job will be to see if they can actually take advantage of any vulnerabilities, if they can actually exploit them to gain any access or to reach, sensitive areas. Their job with that would be to do that and to show how they do it and stop at that point. So then we can use what we've learned from their poking a hole to plug that hole, of course. We can have pen testers that are internal. Large organizations may have full red and blue team, that are set up on a regular basis to act like attackers and defenders and run exercises. We have people that, like I said, vulnerability people might have the responsibility to run different vulnerability assessment tests on a regular basis. And in a big enough organization, somebody might do pen testing on once in a while as well. But also many times it comes in when you bring in a third party. And this is where you get into some phrases like white box or black box or gray box type of testing. And that's why I said it's possible that a pen tester may do vulnerability assessment. If a pen tester is being given the task of doing a black box, in other words, they don't know anything about the network. They've been hired to go and see if they can penetrate that network as a client. And they, of course, have all the proper authorization. We're still a white hat here. And then they're going to have to do their own vulnerability assessments. They're going to have to do their own scanning and enumeration and take a look at everything and find the targets and figure out which ones they're going to try to exploit and then see if they can. And then, so they're going to have to have done vulnerability assessment to then take advantage of some vulnerabilities, but they'll go further and try to exploit the found vulnerabilities, identified vulnerabilities, so that they can actually take and gain some access or gain some data. Their job is not actually to take it out and steal anything, of course. Their job is to show that it could have been done, and this is what a hacker could have done. And so now you need to fix X, Y, and Z. And of course, if they're doing a white box test, then the company has hired them and said, here's everything about our network. You don't have to waste your time scanning it and everything else. Here's our network diagram. Here's our computers. Now now that you know everything, can you potentially get in? And of course, a gray box might be a combo of somewhere in between there where they know some about because they've been hired but not given some more intimate details. One of the things that usually in the beginning class, I mentioned penetration testers, white hat hackers, as a threat actor, technically, because many times you will have a double blind penetration test happen, which is where, say, senior security and IT and just senior management decide, or auditing requirements require, that it's time to bring in that third party outside pen testing group to see what they can do. And we were not going to tell our security team, because then it becomes this double blind test. We've just hired these guys to act like hackers and try to get in, and we haven't told our security team it's coming, so it's a test of them as well. And so this situation is not uncommon and something to be aware of. And so that is the difference. Vulnerability testing is to find the vulnerabilities and document them so they can be mitigated. Penetration testing is actually sort of in a way of analyzing those vulnerabilities and then seeing which ones are the most critical. Obviously, if a vulnerability showed 6 vulnerabilities, but then a pen tester could only use one of those for whatever the reason is, some other, there's an open port but not a service behind it, that's not really vulnerable, there's nothing I can do. Or there's an open port somewhere, but we can put a firewall rule to block it, that fixes that problem, and thus we can't get in. But if the attacker can actually get through the vulnerability and gain some kind of access, then that is something we need to be aware of. How were they able to do that? What did they do? And what do we need to patch or fix to rectify that? So then over the next couple of chapters, lessons, if you will, we talk about secure things like secure protocols, secure networks, secure systems. So let me try to sum up, especially given I took more time than I really wanted to, know that may be the most useful to show and explain all the nuances of the scripting, and so you guys and girls can get through that. But the secure protocols is actually fairly easy. When you get down to it, the simplest way to look at it is use secure protocols. One of the things you've learned already, and you should know from your own past experiences, there's all kinds of protocols: HTTP, TCP, IP, SSH, on and on and on, right? Mail and all these other kinds of protocols. And some of them, say like Telnet, are just inherently insecure. They do not encrypt the information. If somebody can grab the packets, they can see your username and password in clear text being transmitted as you log in with that remote Telnet session. On the other hand, SSH uses encryption, and so that's a more secure protocol. So if you're going to provide some kind of remote command line access, then you're going to use SSH, not Telnet. If you have a choice, always go with the secure, well, and almost always, because if you're going to create file transfer, then you're not going to use FTP most of the time. Again, you're going to want to transfer data from one facility to another. You want to use secure copy, one server to another. You want to use secure copy. And once again, it's using SSH, so we're encrypting that data, and nobody can just sniff along the way and pick it up. But there might be a reason to use FTP if you're just having, like it's still very common on the internet. You may have been to one recently and not even realize it, because the browsers support surfing FTP sites if they're just anonymous public FTP. And so a lot of times if you go to a site like a video card or a software company and there's a patch, they may literally be taking you down into an FTP server to pull that patch off of. And if you paid attention, or you could even see it, browsers like to hide that these days, but it would say FTP : / instead of HTTP. And so the FTP protocol is still in use if we're just going to allow people to pull data down. We don't want to have to worry about it. They can just log in as anonymous and type some fake email, or their browser will do it automatically for them, and they'll be in and they can pull those files. But we're not worried about security there. It's patches and stuff that were publicly available. We wouldn't want to use FTP to securely transfer customer. And I wouldn't secure, so we'd use the secure protocol. So most of the time, the obvious choice is the secure version. Occasionally, maybe an insecure version is okay if you're not worried about security, like in that public FTP site. Or maybe you don't have a choice. Some piece of equipment just, it only has a telnet access, and you need to have somebody remotely manage it. Well, you definitely got to do something a little creative then. There you may have to use VPN, so you can wrap that session around so that somebody can VPN to a VPN adapter. And now that's inside your network from that other office, using VPN to transverse the net. And then from that VPN router to the machine, you can telnet, and that's just all safely inside of your own network. And so, except for your own employees, nobody could sniff that. And so you could basically, set up a tunnel to wrap that traffic in. And so that's really what it comes down to for secure protocols. Use the secure versions unless you don't have a choice, and then secure the insecure versions with some other means. I've seen people do all kinds of things if they have to. It's less and less likely that, but you still see Telnet out there. Telnet's very popular as a way to access network equipment. And if it doesn't have a web interface, it just has a shell or a console or a telnet, so that you can get in and use the command line to drive it. And that's very efficient. It doesn't require a lot of overhead, having a whole GUI. But of course, Telnet has no security. So if you are using that on an insecure segment of your network, or definitely trying to use it from the outside world, then that's not good at all. So we're, once again, we have to get a little creative. So then lesson 8 is about secure networks and system design. And it talks a little bit about some best practices. I think I can leave most of that to you to review yourself. It's pretty straightforward. But once again, the idea is to design security in from the beginning. And so if you are tasked with building a new network, that, if a brand new company, or maybe there's a new office being built, etc., or we're expanding, or we're merging two companies, whatever the task comes to you that you have to do, sort of be involved or be part of a team that's going to architect a network design, then you want to think about how you're going to segment that network, how you're going to use various pieces of equipment that we talked about in this class, from firewalls to other equipment to, and other things you've learned like virtual LANs and things like that. How are you going to lay it all out and design it so that you can have security, isolation where you need to, sharing where you need to, etc. And the same principles, really, to be honest, there's a lot of overlap between sort of best practice network defense design and best practice system. Because when you say systems design, technically in the broadest sense, a system could be a network, right? That's a system. It could be one individual PC. It could be a data center or 3 data centers you're having to build across the world. That's your system. But once again, whatever it is you're building an app, you're building a whole network, you're building a test box, whatever. You want to build security in and think, and of course do all the best average, standard things. Don't leave default accounts, don't leave default passwords, lock down on things you don't need, turn off other services, harden, etc., etc. But from a design point of view, you want to take into account, going back to some of those first couple weeks, things like layered defenses, diversity, limiting obscurity, all those things. Think about them as you go into the process of trying to design that system of that network. And so that chapter has some additional. It has a really good example of some different web design ideas, how you could start off and kind of add more complexity to that. And then there's some best practices, and then one of the things about the exercise is that I believe this is the exercise where you have to sort of label where certain things go in a network diagram based on kind of this concept. So if you have any questions, let me know, but it should be pretty straightforward if you kind of think it through what would belong and what kind of equipment you'd use. Then lesson 9 is about secure deployment. So we talked about secure protocols, and now secure systems and network, now secure deployment. What does that mean? Well, it means one of two things. Deployment is deploying something, right? We're going to deploy troops out into the field. We're going to deploy new software into our organization. We're going to deploy an update, patches. So anytime that you're doing that kind of stuff, then there are some things you need to take into account. Let's talk about it from, say, sort of the more system administrative side first. If you're doing patch management, for example, you're going to want to do secure deployment of those patches, and you're probably going to want to take on a number of different possible concepts. one of the things you find in these types of deployment models is usually there's some environments. There's like an initial development environment. So whoever is the developer of that app, in the case of a patch, that's outsourced to a third party, but somebody develops it, and then it goes through some form of testing, and then of course it's pushed out to ultimately the production environment. And so the software as a patch comes to us, and we don't want to, in other words, then jump straight to throw it on every machine. No, hold it. We want to test it. So we may have automatic tests that may happen in the process. We may have a virtual machine that we want to put it on. We may have physical hardware that we want to install it on to make sure it works. And then once we've done some testing, begin to roll that stuff out to the rest of the organization. So, but you may be thinking, Lee, everything goes automatic updates, which is thankfully not totally the case in enterprise versions of Windows, but for home it is for the most part. But don't you want automatic updates? Well, in principle, you do want the updates, especially security updates, as quick as you can. But it is true that in a corporate environment, updates from vendors can break things. And so that's one of the reasons you want to make sure that, just because Microsoft puts out an update, they may have done something that ends up breaking an internally developed app or breaking communication with a different system. I had this happen with a company I worked at years ago where a bunch of Windows updates just automatically rolled out, and we were a mix shop. We ran everything. A lot of people were on Windows machines, sales and accounting, etc. All of our design were on Macs, and then our production servers and development servers and live servers were mainly Linux with a mix of a few other Windows and Mac servers as well, font servers and things. And so, but there was a lot of, it was a very happy network. Everybody talked. The production people could take a PDF and put it onto a server that then the Mac, even the Windows people could get to, because we had set up basically a share. Everything worked beautifully, and then we rolled out this. We didn't do it. It rolled out this patch. This was a lesson learned years ago at this company, and all the Windows users couldn't see anything on the Mac network anymore. And so designers couldn't get their proofs to the salespeople to send to clients, and it was just a nightmare. So we had to figure out which one it was, revert back, roll that patch back, spend the whole day messing with that, and we were slow responding to clients. Literally had old school stuff where a designer would take a file to the salesperson on a flash stick, kind of thing, because we literally couldn't use our internal network between Macs and PCs because it had been broken. Because of an update to the SMB protocol that Microsoft pushed out. They're not well known for following specs exactly. They have a tendency to do things their own way, and in this case, they broke the interaction with the SMB and Samba on our Linux and Mac machines. So we learned at that point that from now on, we would no longer do automatic updates. Instead, we would have test machines that we would immediately push those updates to, and then run a battery of automatic tests using some scripting, to automate those tests. Okay, can this machine open a file on, that machine? Can it access the font server? Can it copy a file to that machine? Can it do all these things? Can it access all of our systems? And is everything working? And if so, then we pushed the rest of that out. And of course, we were a small enough organization that at that time we pushed it to everybody. But a bigger organization, many times they do a phased rollout, even after they've gone through this set of testing. Because, even with testing, you've tested on a VM, you've tested on maybe one system, but you have 10,000 machines in your organization, and then you start rolling them out to all of them. Well, many times it's best to roll them out in a phased rollout, and, pick the departments that are kind of, if they're down for a while, because once we push it out, it actually finds that 1 in 10 machines have a problem, and our one test box wasn't 1 in the 10, right? So then we have a problem. If we only push it out to one department at a time, then we can maybe catch that before we roll it out further. Now, the same principles apply if you're developing your own software, except that you add some additional steps of you're the development, and then you need to do some testing of that before you even begin to get to the next stages of user acceptance and finally rolling it out to production. And there's a lot of things that can be done to automate and make software more secure. You can run what are called unit tests in your repos and in your environments. You'll learn a little bit more about this, I believe, in the web application security class, and as you go on in the program. But there are things that we want to make sure as programmers that we're doing. Are we making sure we've sanitized our inputs from the users? Are there any calls within programs that are risky? And so we can automate test, set up tests that automate to make sure that certain things are being checked, even as our developers are writing and checking in code. And then when we get to a version that we want to test, we can put it into the testing environment, and then we can put it in the staging environment, and then we can finally push it out to the live environment. So that's a secure deployment, and it applies, like I said, both to, and usually that's the model. You'll have a development environment, testing environment, a staging environment, and then a production environment. So there's multiple steps of secure deployment. So then the last lesson for today is an overview of, we've mentioned them before, and the term will come again, but embedded systems and IoT, or the Internet of Things. And as far as I'm concerned, that's my opinion. There's so many different definitions of the Internet of Things, but to me, the Internet of Things are really just another name for embedded systems. Embedded systems are taking computers and putting them into, and where they really have shown up the most is at least to date, embedded systems are in manufacturing a lot. But you can also probably, if you don't have a super old car like me, and even mine has a few, but you can walk out and look at your car, and you probably have a dozen different embedded systems. The brakes have their own little controllers to help do that anti-lock braking and all that little micro pumping they do to keep you from locking up your brakes. That there may be one at each wheel, so it's an embedded system to drive and control. That there's an embedded system for the ignition and fuel injection system. There's embedded systems to probably, to run your entertainment center now. You may have a monitor in your dash that can play movies and show GPS. So you're in a car that not even 100 years ago was just a piece of metal with an engine that cranked in the beginning, and the little Model T ran down the road, and they used to say you could have it any color as long as you want it in black. And today, now we have a car that still does all the things of driving down the road and still gas powered and all that, even though unless you have a Tesla or some of the few others, but you get the point. But now they have all these other things. And so lots of complex systems are actually really multiple systems. And so, but we've also seen this a lot in manufacturing. A lot of manufacturers will use embedded systems to help control manufacturing process. And I'm not talking about, which is an example, I'm not talking about the robot arm that's doing things, or even a robot. Those are embedded systems or robotic systems. They're embedded into manufacturing. But I'm talking about smaller, like sensors and controllers that, speed up or slow down the conveyor belt or something, that kind of stuff. And so here you have a system that's purpose is to monitor this network, or not the network, to monitor that manufacturing process and report on every machine that comes out, measure them, and make sure their tolerances are with their intolerance. We have embedded systems along the whole assembly line to control. And so if something happens, then we can slow down or speed up those and change those systems. In power plants and refineries, we have embedded systems that are monitoring pressure, opening and closing valves automatically, all kinds of things. And so that is how manufacturers and some of these things are controlled. You don't want to have to send somebody down into a dangerous place theoretically to open or close a valve if you can control that automatically through a system, right? Especially say like in a nuclear power plant, minimal exposure to the radiation. People stay in the shielded areas and don't want to go down there. A lot of that's automated through embedded systems. So what is the Nest thermostat? Well, it's an embedded system, in my opinion. We may call it an Internet of Things device, but it's a thermostat that now has a computer and Wi-Fi, and it can talk, and you can control it with your phone. So that's not just like the slide bar old school thermostat of years and years ago, or even the programmable ones that were kind of like a calculator, had their own little bit of memory. Now we have there's a mini computer in there. This thing is using, internet connectivity to talk back to the server, and through that to your app, and tell you the temperature. And of course, it's smart and learning, right? And so that it sees when you normally turn it down, and so that it tries to anticipate, saves you energy when you're gone at work. And this is amazing stuff. But all of these things are just examples of what we've been doing on the manufacturing and industrial side for a number of years. They're just becoming consumer products. And in all cases, because their goal is to do X, control the temperature of your house, control this assembly line, in many cases, security hasn't really been thought of well. And so we're going to see that the implications of this are going to become very huge as we go forward. And for us in the future, I think this is going to be a huge thing. We came very close to seeing a refinery in the Middle East blow up last year. And this is a story that's just now coming out this year as some of the information is coming out and being put out by researchers that have been involved. But the ability for hackers to be able to mess with systems in a way that can cause real world harm is here. We haven't quite had it happen yet to that level. We have, in a sense, the power grid of Ukraine has been taken down. Other types of systems have been messed with, but in the sense of just all of a sudden, for no apparent reason, a facility just blowing up, that hasn't quite happened yet. But it almost happened last summer, and I guarantee you it will happen soon enough because somebody will figure out what they didn't do right last time, and the wrong people will get their hands on this code as it continues to circulate, and people get the idea, and just like more and more kids can now attack with because the tools are automatic, then attacking this stuff, and it's already had a huge impact. Some of the biggest denial of service attacks that have happened in the last few years have been driven by millions of Internet of Things baby cameras and devices that have all been brought home and plugged in with default passwords and then taken over by hackers to be able to use them in other types of forms. So we're going to see many, many more implications of those, and we'll see some more discussion of those in another class. That's covering all of them today, and a little bit of finishing up last week with the script demo. As usual, if you have any questions, let me know. Let us know on Slack. We're seeing a little more activity in the channel. Happy to see that, and we're always poking in. And if you message me directly, I'll know about it as well. This will get posted up here a couple hours from now when I get all my lectures done today. And I'm hoping that you folks in the system admin will finish up, and we'll see you in network defense next week. Thanks.